Okay, now we are going to same case, the same case. Now we want that the results should be post processed in the CFD post. Okay, and CFD post has the advantages that it can like store the its settings. Okay, and you can create the multiple graphics, and they will be stored as a like objects on the tree outline. This is also been done here, but we cannot edit them and change the location. So it's much easier actually. It's even they are now providing the similar feature to the Fluent also, but it's a much more better in quality in terms of the post processing. But definitely the Fluent has the advantage that you can post process results very quickly, and it's a very handy options are very easy to use in the Fluent as compared to CFD Post. But the CFD Post has a more professional type of the graphics quality. Okay, so I'm going to open the CFD Post, and let me copy the, okay, allow them. Okay, I'm going to copy the path the path of the file where we have stored them, and click on load results. In the file name, first I'm going to paste my working directory and the folder. So now we are here. Okay, so I'm going to open the our case and data file, that is the wind turbine dot case and dot date. Okay, and now click on open, click on OK. Okay, first of all, make the single window, it's a single case, so make the single window. And first let's play with some contour plots. Okay, I am going to select all the blades. Okay, so select the inner domain. Okay, accept the interfaces. Okay, and also periodic boundary conditions. Okay, and make the range as local and apply. Okay, now adjust the different windows on the your screen, and click on the contour. Okay, so this is the contour plot for the wind turbine blade. Okay, you can hide the this wireframe from here. So now you can display them with the better visibility. Okay. Okay, here you can like put the more layers here. So let's make it 40. Okay, let's try to display them also on the periodic boundary conditions, and what you feel here. Okay, I'm going to make one plane. So iso surface again, and that plane will be from the constant z location. Sorry, x location. Okay. Okay, here. So from the contour plots, choose the. Okay. Also, I'm going to display the these geometry parts. Okay. Here are the results. You can see. Okay, now let's create the some planes where I'm going to display the vector plots. Okay, so location and this is isosurface. So it's going to be the again the z coordinate actually, and let's try with the first the 12 meters. Okay, and don't display the periodic boundary conditions and display the vector plots. Location is the isosurface number 2 and variable is the velocity. So velocity, simple velocity means this is going to be the relative velocity. So relative velocity is displayed here and so maximum number of points, okay. Vertex is clear. Okay, now display. Okay, we play with a few things here. First is that I'm going to hide the plane. Okay. Number two thing is that the something is not visible here. Okay. Next thing is double click on the vector and the color is the variable. Make it local one. Okay. And I'm going to use a symbol as size as a 0.18. 1.5 or 1 byte is okay. Apply. Okay, make it maybe the half value 0.08. Even lower, so 0.02. Okay, can you feel one thing that it is like in the Fluent this was showing the wrong values. It was not showing the relative velocity vectors. It was showing the I didn't like tell you at that time because I don't want to make you confused. At that time, even I was showing the absolute velocity and the relative velocity, and they were showing the same, and it was actually a absolute velocity. That's why they were not aligned with the blade profile, and also they were showing a lot of separation. But this was not the case actually. So now in the CFD post, you can see that we are seeing the results in a very nice way. So here you can see that it is striking here. It should be slightly maybe on this side. So maybe if you can give the like a 2 or 3 or 4 degrees pitch angle, global pitch angle, then this will be sorted out. Okay, but right now results are okay, so we don't need to worry. Okay, now I will change the location of the ISO surface and make it like a 20 meters. So everything will be scaled, will be changed accordingly. Okay, this is the benefit I was telling you. And here I am going to change the scale to the 0.01. So again, it is showing you the very nice results, and there is no separation and flows attached, and it is showing the proper way of displaying the results. Okay, so it is going very well. And you can also see the development of the boundary layer very nicely. Okay, Now change the axis surface to the, let's say, 30 meters and apply. Okay, I will zoom to the required location. And especially on the, as we are going spin wise up in the upward direction, you can see that the alignment of the vectors are looking very nice actually. So if I go to the vectors and change the symbol size to the point 005, so this looks better now. Okay. Okay, now I am going to change the location to the, let's say, 50 meters. Okay, let's change the values to the point 001 or make it maybe point 002. Second way is that you can normalize. So if we normalize them, then everything will be all right. Okay, but they will show you the same size for every vector plot, every vector, but the colors will determine that the what velocity we are having here. Okay, it's your choice again. Okay, so the next thing is that we are going to move it towards the like a 62.5, same as we did in the Fluent case. Okay, 62.5. Okay, so now zoom the location and same thing again, we are going to do same thing, that is to change the size of the vector plot. So let's make it 0.001 or maybe 0.30 and 7. Okay, display the one thing more I want to display is the y plus values. So it's a y plus, y plus, and it's going to be local value, and it's on the all the parts of the blade geometry. Okay. Okay, you have to hide the display of the geometry so that we can see the contour plots very easily. Okay. Okay, now click on again on the your contour plot. Maybe you consider to hide the uncheck the vector plots. So the same values as we have seen in the case of the Fluent, it's at same location. Maximum value is the 8.84, but minimum value is the 6.86. Okay, this is maybe because of the display of the not the very near to the wall values. Maybe it means maybe. Okay. So what we are having here. So let's see the advanced properties. Variable location is a vertex, is a face, linear. Okay, color. Okay, you can also change the color map. Okay, so from the traditional RGB to the arrow. Okay, so red, green, and the blue. So now it's the arrow one, and let's say the variable location is on the faces. So this is a new thing I'm seeing in the latest version of the Fluent. So let's see what we get here. Same thing actually. Slightly different value. Now it's a 2.49 to the 900 actually. Here you can uncheck the show line colors. Okay, so now this is like we have done the post processing in the Fluent also, and in this class I have shown you that how you can post process results in the CFD post. Thank you very much.